So hi everyone, I am going to explain you about the solar cell, how to do this experiment. So the aim of experiment here is to determine IV characteristics of solar cell. Okay, here the apparatus required are solar cell, emitter, voltmeter, resistance box and bulb. So you can see I have made here the circuit connection according to the given circuit diagram. So here is the resistance box, emitter, this is the 60-watt bulb we require. You can also go to the sunlight and you can perform experiment, but here you can also use the 60-watt bulb, so that should fall on the solar cell. So here we have taken one part here. So the solar cell we are considering. This is the panel. So along with that we are also going to study the spectral response. So here are the different colors of colors we have chosen. Spectral response I will also explain you. Then this is the digital voltmeter to measure the voltage. We have to use this, and for this is to measure current. So here is the circuit diagram for this solar cell performance. Resistance box, emitter, and this is solar cell across voltmeter. Okay, according to that this circuit connection we have made. So the next first you need to understand what is solar cell. Solar cell is what a PN junction diode which converts solar energy into electrical energy, or radiation light into electrical energy. So this is the relation for PN junction diode for current and voltage. Already you have studied the theory of solar cell. So here I will explain you the procedure how to measure the reading, and here you have to find out fill factor as well as efficiency of the solar cell, and this is the nature of graph to calculate maximum power, current versus voltage, and this is for the spectral response, power versus resistance. Okay. So here are the observations you should note down here. Distance between filaments and solar cell, that must be 10.5 centimeter. Area of this solar cell, you have to measure, already they have calculated here. Length into breadth, this is about 28.6 centimeter. Voltage of the bulb 60 watt. Input power, so this you have to calculate using the 60 watt of this voltage bulb. Then short current, zero resistance, open circuit voltage. How you can do it? Just what you have to do here, you have to open circuit voltage. For that you have to remove this infinite key. Then current must be 0, you can see. So the current is 0 and it must show some reading. Voltage must be having some value. This means this is what open circuit voltage. Then you can confirm that the circuit connection is correct. Just keep this key as it is. Then here what you have to do, power maximum. So once you do the experiment readings, if you take, you can calculate a maximum power, efficiency and fill factor. So let us do it. Here is the tabular column, resistance versus current, and then voltage, power. So first you need to apply here resistances from 4 ohm to up to 64 ohm, means around 10 to 15 readings you have to take to calculate the maximum power. Okay, for this corresponding resistance you have to note down here current and voltage in the voltmeter for 4 ohm. So like that you have to repeat the procedure. and you can calculate power using current into voltage. So let us do this. So here let us take the first reading. So 4 ohm if we apply. So here the ammeter reading you can note down here, it is 4.04, more than that, near to 0.05. Here it is 0.2. 0.2 divided by 10 division is how much? 0.02. Then 1 division is 0.02. Then here we have in between the second and third line. Then it is around 50. Sorry, 0.05 ampere. If we write in terms of milliampere, here also they got around nearly 50 milliampere or 48.6. Okay, for applying 4 ohm resistance, and corresponding voltage also you can see 1.19. Here also they got 1.2. So for 4 ohm, like that you can just repeat the same procedure. Apply here 5 ohm, then here we should remove for 5 ohm this key and 5. Okay, so here you can check the current and voltage. Here they got here also around same 50 or 50 milliampere. The corresponding current, the voltage is 0.3. So here for 8 ohm they got 48.1 and 1.2. So like that repeat the same procedure for applying different resistances and measure current, voltage and calculate power. Here for the next reading I am going to apply 8 ohm. So for this let us remove here first 2 ohm and 5 ohm. Okay, here also you can see it is also around 0.05 ampere, and here voltage is also 1.22. So you can see they also got for 8 ohm around nearly 50 milliampere or 48.1 and voltage 1.20. So like that you have to apply different resistances in the increasing order and measure the current and corresponding voltage, calculate the power. So here you have to plot the graph of current versus voltage. So the nature of graph, the graph you are going to get like this, and here you will have the maximum power from this graph. So from the graph they got maximum power of 17.47 and input power that you have calculated here from the 60 watt bulb, that substitute here and you will get the efficiency. Okay, so maximum power here from the graph I max versus V max, maximum current into voltage. Just substitute in this formula to calculate efficiency. Then fill factor, once you calculate the maximum power you can also calculate fill factor, and here you require short circuit current that is about 44.5 milliampere, and here open circuit voltage you have to substitute, then you will get the fill factor. So graphically fill factor you can calculate using the maximum power that you obtain from graph. So they must be near fill factor from graphical and theoretical. So 1.05, 1.23. So here we are also going to perform here spectral response of the solar cell. Spectral response is what? Sensitivity of a optical photosensor to the optical radiation of different wavelengths. So here we have given here different colors So this is red, blue, green, and this is red glass. It is a little bit broken, so just we can understand how to do the spectral response of a solar cell. So you can use different colors here, and here is the tabular column for the spectral response. Voltage you have to measure, spectral color red, green, blue. 3 colors we have taken here. Wavelength of these colors you have to write down, and energy you can calculate once you know the wavelength. Current you have to measure in the ammeter. Once you measure current and voltage, you can calculate power for these different colors. So let us do with this green. I will keep it on this solar cell, and you can just note down here the old current. So it is around and one more thing, you have to apply here 50 ohm for each different colors. Constant resistance you have to apply 50 ohm. Okay, then you can see the ammeter reading. It is around 0.02 or in between 0.2 and 0.3, and here voltmeter reading 1.17. So here they got voltage 1.4, and current also they also got around in between 0.02 and 0.3. That in terms of millimeter is how much it is, 24.18 milliamp. Okay, if you can measure this current and voltage, you can calculate power. Like that you have to do it for different colors. This is for green, and then next repeat for blue and also red. So after applying 50 ohm, you can just see here the for this color green, we got the current of about point or a very small value of current, point around 0.01 or between 0.01 and 0.02. That means in terms of millimeter it is how much here, and voltage around 0.8. So for the green color they also got 1.8 volts, and current 14.22 in terms of milliampere. So corresponding power you can calculate. So like that repeat for red and blue color, and this is the calculation for energy. So fill factor already we have calculated in the first part. So this is how you can do the study of spectral response of solar cell. So in the end you can write here result, that is efficiency of solar cell, how much you got. You can write 4.18% they got. Fill factor of solar cell theoretically and graphically. So this is how you can perform this experiment, solar cell. I hope this video is helpful for you. Please like, share and subscribe my channel. Thank you for watching.